So we're going to look at standard and vertex form of a quadratic equation today. And so the first thing we need to remember is that a quadratic function, when it's in standard form, has a very specific form. And so I'm going to get out some pens so I can color code. And so it is ax squared plus bx plus c. And so that's the standard form. When we get to solving quadratics, that'll be super helpful. It's in descending order. A, B, and C are all numbers, and when we use quadratic formula, those A, B, and C values is what we're going to plug into the equation. So a quadratic function creates a U-shaped curve called a parabola. And so using your graphing calculator, we're going to sketch the following function. So I've got my calculator. You are more than welcome to plug it into Desmos, or you can just watch here. We've got x squared plus 2x minus 5. I type that right into my y equals, hit graph. And we get a nice little horseshoe. And so we'll just kind of sketch that here. So we know the vertex, this point, is a little bit to the left of the y-axis. So we'll just say something like that. Doesn't have to be perfect. So then if we go to the second equation over here, we'll type that in. So negative x squared plus 3x plus 7 and see what that looks like. And if you'll remember from our transformations, with a negative in front, it actually reflects it over the x-axis. And so when we draw that, I'm just kind of sketch it here. It makes an N shape. And so this A value in front over here is a positive 1. The A value over here is a negative 1. This little blurb down here tells me if A is positive, the parabola will open up. If A is negative, then the parabola will open down. So just like over here. So with the parabola, we've got some different things that we can identify. So the vertical line that divides the parabola into two equal parts is called the axis of symmetry. The axis of symmetry formula we're going to use is x equals h if it's in vertex form, or x equals negative b over 2a. The turning point of the parabola is called the vertex. So when the vertex is the lowest point, it's called the minimum. When it's the highest point, it's called the maximum. And so what that axis of symmetry really does, I'm going to go ahead and draw it up here. It's a vertical imaginary line that splits your parabola into two pieces. So one side will be increasing, one side will be decreasing, but it's on opposite sides of that axis of symmetry. So the vertex form of a quadratic function is when y equals a times x minus h squared plus k, where hk is the vertex and x equals h is the axis of symmetry. And then a, that value in front, determines the width and direction of the parabola. So is it fat? Is it skinny? Does it open up? Does it open down? And so we're going to practice a little bit with that. We're going to look at some examples. So the directions here say to use Desmos to graph each function and identify the characteristics. Since I'm making this video using the Elmo, I'm not going to be able to share my Desmos screen, so I'm going to do it all on my graphing calculator. But you are more than welcome to use Desmos. So, first things first, and it's a lot easier to use Desmos, and I'll probably throw in a video at the very end where you can actually see me using Desmos. But for right now, I'm just going to be using the calculator. So, this first example, I've got a negative 3x minus 2 squared plus 7. And so when I graph it, I should get a parabola. I do. And so we know a couple of things already. From the transformations, we know that this graph has been reflected over the x-axis. We know it's been vertically stretched, so it's got skinnier by a factor of 3. We know that the vertex has moved 2 to the right and 7 up. So my vertex, if we identify the H and the K, is a positive 2, 7, and I could look at my graph and find that. Since my parabola is opening down, we do know that it is a maximum. And we know that my axis of symmetry is x equals my h value. My h value ends up being 2. And so just with that information, we can go ahead and graph a little bit over here. So 2, 7 is my vertex. My x-intercept, so that kind of helps me. We'll go to my table and pick a couple more points. And on Desmos, you would just point and click. So we've got a y-intercept at 0, -5. And we have a couple of points, 1, 4, and 3, 4. And then 4, -5. So we've got a nice little shape for our parabola. So we can go ahead and sketch that in. And so then we're going to fill out all of the other information. So the domain, since I've got arrows on both sides, I know goes from -infinity to +infinity. My graph for the range goes bottom to top, so the bottom of my function never stops, so we'll start at -infinity, and it stops at the vertex. But the y value at the vertex is 7, so my range is -infinity to 7. We start by increasing. I'm going to go ahead and draw my axis of symmetry there so we can see exactly where that dividing line is. We start my function increasing, so we'll start at the beginning of my domain, and we end at the x value, so we end at the axis of symmetry, and then we decrease the rest of the time. My zeros is where it crosses the x-axis, and those aren't exact. So we can say between 0 and 1 and between 3 and 4. My y-intercept was 0, -5. That was exact. And then we've got positive, negative, and end behavior. So this region of my graph is positive. It's above the x-axis, and it goes from one x-intercept to the other. So we'll say it's positive. We'll say about 0.2 until about 3.5. And it's negative the rest of the domain. So it's below the x-axis the rest of the domain. And we've spent a lot of time practicing with that, so I'm not going to explain that super in depth. You can go back and look at the characteristics video. And then my end behavior. We're going to have as x approaches -infinity, so the left side, my arrow is pointing down, which means that f of x is going to approach -infinity. And my right side, as x approaches +infinity, has an arrow pointed down, which means that f of x is also going to approach -infinity. And that is all the information. So we're going to keep practicing with that. So in the next one, in that number 2, we've got a 1/2 x plus 4 squared. Before we plug it into our calculator, we can already identify h and k. Since there's no number visible, we know that we add 0 at the end, and that would be my vertex. So remember, h is always opposite. So my vertex is at -4, 0. Since my a is positive, we know that it's going to be a minimum. And my axis of symmetry will be x equals -4. So then we'll go ahead and plug that into our y equals, see if we can get a general sketch for the graph. So transformations wise, we know that that 1/4 in front is a vertical compression. We know that this +4 moves it to the left, and that's it. So my parabola is pretty wide. I don't know if you can see that. We'll go ahead and sketch that graph. So we'll go to the table and see if we can pick some points. So we know the vertex is at -4, 0. We've got a y-intercept at 0, 8. That's always an easy one to graph. And then we'll pick a couple of others. So -2, 2, -6, 2. And then the rest aren't whole numbers. So we'll just kind of fill it in there. We know enough about parabolas where we can sketch it pretty accurately. Which we've got arrows on both sides, which means the domain is going to be -infinity to +infinity. The range is bottom to top, so the bottom of my function is at 0, and the top of my function is at infinity. And really, this should be a bracket up here too. My axis of symmetry goes through the vertex. It's a vertical imaginary line, so we'll have x equals -4, which helps us figure out increasing and decreasing intervals. We start by decreasing, so we decrease from the beginning of the domain until that axis of symmetry, so until -4. And we increase from that axis of symmetry until the end of the domain. My zeros is where does it cross the x-axis? It actually touches at -4, 0, so it actually touches at the vertex. And my y-intercept was also exact. It was at 0, 8. The whole thing was positive, which means it's going to match my domain, and it was never negative. And my end behavior, if I were going to look at it, would be up, up. So with the proper notation, we would have as x approaches -infinity, so which direction is the left side going? Well, it's going up. And then as x approaches +infinity, f of x is also going up. So the left side is going up is what this first line says. The right side is going up is what that second line says. So let's look at a couple more examples. We got 4 more. We're going to look at different parent functions as well. So we're going to look at another parabola. So this one, -x² + 6x - 7, we know that negative in front produces a maximum. We can't identify the vertex from this form, but luckily it's already graphed over here. So my vertex is actually going to be 1, 2, 3 over 3 up 2. So vertex is 3, 2. And you can always type that into Desmos and check for your vertex that way as well. Which means that my axis of symmetry is x equal to this x value. So x equals 3. And I'll go ahead and draw that in the graph. My domain, if we assume that this graph continues on forever, my domain, since I've got arrows on the left and the right, we'd have a domain of -infinity to +infinity. My range is bottom to top. The bottom of my function goes down in the negative direction forever, but it stops at that y value at the vertex, so it stops at +2. My function, if I trace it left to right, begins increasing, so it increases from the beginning of my domain until the axis of symmetry, and it decreases from the axis of symmetry until the end of my domain. Zeros, not exactly within a coordinate where those cross perfectly. So we can say between 1 and 2 and between 4 and 5. And we will get those exact when we start solving quadratic equations, but we're just not there yet. My y-intercept, we can't see it on this graph, but we're going to look it up real quick. So we are actually going to type it into the calculator. If you use Desmos, just scroll in and out on your screen until you see where it crosses. So I'm going to graph it, make sure it looks the same. It does, and then I'm going to go to my table and find where x is 0. So my y-intercept is 0, -7. And what you could begin to notice there is that that -7 matches that c value. And so we'll talk about that a little bit later. And then we've got positive and negative. So we know above the x-axis is positive. And so that's between my two x-intercepts. So we'll kind of guesstimate. So we'll say about 1.6 until 4.3. And those don't have to be exact. If you're using Desmos, you can get the exact values. And then negative is this piece over here and this piece over here. So they've got a break in the middle. So it's negative from the beginning of my domain until that 1.6, and it's negative again, picking up at 4.3. End behavior, if we were to say it as simply as possible, we would say down, down. And so mathematically, as x approaches negative infinity, so the left side, f of x also approaches negative infinity. And then as x approaches positive infinity, f of x approaches negative infinity as well. All right. We were not really able to notice the transformations from this function here, but we know that a regular parabola kind of looks like this. So we know it was reflected over the x-axis, and we know that vertex, originally 0, 0, has shifted to the right 3 and up 2. So we could identify those transformations a little bit if we wanted to.